Good day, viewers. I'm Engineer Johnson George. This moment, I'm very brief. I'll be educating my viewers on electrical solar protective system. It is not all about installing the solar system, but it's all about protecting it against thunder effect, excess voltage, and feedback voltage. Some of these things can cause disruption to the solar system, especially at inverters. And again, now if you look here, I have some devices very important. Now, this is a surge. We have this as a DC surge. We have the AC surge. Now, they are protective devices, as we call them. We call them solar protective devices. These are SPDs, so which can help our setup. When we set up when we talk about, some persons don't really understand, we talk about solar. Solar installation setup system or designs has to do with four major components. The first component you have that makes up that system, we have our battery. The battery is like the storage device that stores energy for to be used anytime you want. So once that battery has energy, the inverter converts, which is the second component, the inverter converts the energy from the battery, which is a direct current voltage, to an alternating current voltage, which can now be used to power our electrical appliances or equipment. So in that case, these systems need to be protected. And again, then we have another third component which we have as the solar panels. The panel on its own are made up of some photovoltaic cells that helps to radiate charges when exposed to sunlight. So when these panels are exposed to sunlight, it generates energies that converts these cells to electrical charges that helps to charge our batteries. So that will now take us to the the fourth component rather, which is our charge controller. The basic aim of that solar panel is to charge our battery. But sometimes, like we have, when the intensity of sun is high, the charges might be high. When the intensity is low, the charge current can also be low. So then we have the need that there should be a need of a device, which is the charge controller, which helps to regulate the charges that is coming from the solar panel down to our batteries to charge our batteries. So when the batteries are charged, the inverter can now use the battery to the energy in the battery to power our electrical appliances. And these systems need to be protected very importantly, because our solar setup systems are very expensive. From the batteries, they are very expensive, to our inverters, very expensive, to solar panels, expensive, and even the charge controller. So imagine that you are now putting into millions in installing a solar energy system to power your house, and suddenly maybe there is a thunder lightning or there is excess voltage that will flash up your system, and before you know, the entire system is packed up. The inverter is packed up, or the charge controller is packed up, or at the end of the day, what kind of job is this? And you now put in money again for more maintenance. So that is why here I have with me a surge. This is for AC surge. Okay, the AC surge or the DC surge are most the same, because the DC has to be direct current and the AC has to be alternating current. So now this surge helps to protect our systems. Now when the current the batteries are connected to our inverters, we also need to check up our system. And when these batteries current are being used by our inverters, which is it has become an alternating current from the inverter. So we need to have our devices. So here we have also a breaker. These breakers help to, they are rated in different capacity. Like some of them, we have some AC breakers, we have in them in DC breakers too. Once the current, every system is designed to have a specific amount of current to pass through. Once that current, it senses the current that is more than what it is programmed to pass, the breakers on its own will just go off and the system will shut down. So again, for our surge, when we have excess current in the system, for example, just like we have roads, when a road is designed with a drainage and suddenly there is a rainfall and the road is being flooded, you see water begin to from the road enter the drainage and they will flood away. After 2, 3 hours, as the case may be, the entire road is dried after the rainfall. So that is what the function of these surges. When you have excess current in the system, especially either in the AC end or the DC end, those excess voltage will pass through this surge, and especially when you have good earthing system in your house. Very important. A good earthing system also help to protect our inverters against thunder, lightning, and other excess voltages that can destroy our inverter. So our surge devices are very, very important when it comes to designing our solar system. And another again, we also have, we call it the AVS, automatic voltage stabilizers, or some regulators. We just put in, when you power the system, the current that is coming from your NEPA grid to go into your inverter, okay, need to be checked. Because if those currents that are going into the inverters are over high, or you have high voltages, sometimes because of, especially Nigeria, we have poor maintenance culture when it comes to maintenance around our transformers that we use in their domestic environment. Sometimes the neutral lines of those transformers can go bad, and you see the lifeline will increase voltage, and which will bring back a feedback to the appliances in our homes that we are using. And when these devices are set, here we have some knobs that you can use to set these devices when they are on, to regulate the amount of voltage you want to enter into your system and current. Once you set these things, if you have excess voltages that are higher than what you programmed there, it will just trip off and that system will be protected. So that is why we have this system. So we see have other breakers, some of these breakers that can be used on our input end, from the current coming from our NEPA grid input down to our inverters can be protected. So once these devices are put in place, our surge is put in place, our AVS is put in place, our breakers are put in place. Before you use, the system is being protected in case of any high voltage or excess current, as the case may be, or during thunder effect. So this system will be protected. Again, very importantly, that your building, I think it is also good, especially when they are high-rise building, to have thunder protective systems like your thunder arrestors. Very important. They also help to safeguard, especially these solar system setups. So thank you for watching. Phone numbers are there. You can call for verification, for inquiries on how you can set up a good solar systems that can also last long, especially in our system. If you have any questions, whatever you want to know much, you can call, you can DM. We're always available to serve you better. Thank you.